Okay, it says let R be the region enclosed by this graph. And the horizontal line y equal 4. So here's y equal 4. They give me a picture, that's helpful. This is the equation right here. Okay, find the volume of the solid. Finding volume when R is rotated. So rotated means we're going to have slices that are going to form either circles or circles with holes in the middle. About the horizontal line y equal -2. So that means the axis of rotation is down here at y equal -2. So remember that when this region rotates, don't really care to ponder what the solid shape will look like, or an interesting donut of some sort. All I care is the center of every slice. The center of every slice is the axis of rotation right here. So that means if I start at the axis of rotation, I'm starting at the center of the slice. If I go like so, I can find the radius of the entire slice. So in this case, the radius of the entire slice never changes, because as I go as far as I can to catch the entire region, the radius of the slice is always going to be 4 above the axis, 2 below, or you can always take y at the top, subtract y at the bottom. So that means the outside radius of the slice is always going to be 4 subtracting -2, or 6. That's the radius of the entire slice. I'm looking at the radius of just the hole right here. That's this radius. So depending on the location of the slice, that radius is going from the function to -2. So I call that my inner radius. So that's going from the function called f to -2. Or you could write it as f of x plus 2. Okay, so I've got my radius and everything. Let's see what I wrote down here. Perfect. All I have to do is take that outer radius. That's the entire slice. That gets squared, multiplied by pi. This will calculate, right here, the flat area of one slice. And then I take the cutout. So that was my f subtract -2. That's the radius. So that blue is the radius of a cutout. The cutout is a different size at every different x. Take that radius, make sure you have these brackets or parentheses, square, multiplied by pi, that takes care of the cutout. So everything inside these green parentheses, that's calculating the flat area of a slice at a given x. Multiply that by dx. Now have the volume of a slice at a given x. Do that computation repeatedly from x equals 0 to x equal b. I had to go find this intersection right here and mark that down. So the way points are awarded is the integrand is the red box, including the dx. Forget the dx, they'll give you 1 out of 2 points. Can't mess up any parentheses or any squared. It's got to be exactly right. The limits are 0 to b, as long as you have told them the value of b. They'll give you 1 point for the, you've told them the value of b, and you have the correct limits here on your integral. They'll give you a point for that. And then you get 1 point for the correct decimal result. So 1 point if you have this answer perfect to 3 decimals. So 4 total points on that problem. These are just 2 other ways to write the answer. Those ways are also valid.